Data logging is a popular application use of the USB 6009. With 8 analog input channels, you can acquire and store quite a few signals. The total throughput rate of the device is 48,000 samples per second, so if you are acquiring all the same time, you could have up to 6,000 samples per second per channel. So let's set up our acquisition to acquire one channel at 1 kilosample, but first I would like to describe for you the setup that we have. This is the USB 6009. Here I have a potentiometer that's wired up to it. This side we take the 5-volt supply of the USB 6009 and wire it to the high side of the potentiometer. On the other side we wire the potentiometer to ground of the USB 6009, and then in the middle, as the potentiometer varies between 5 volts and 0 by turning it, we will read that with the analog input channel 0 of the device. So next we'll switch over to LabVIEW, which is our graphical programming language. It will let us set up our data acquisition task, but also preserves the flexibility to expand beyond that. So we'll go to the front panel, we'll click right, and we're going to set down a waveform graph. We'll put our first graph on and it's ready to go as is. But in this application, we'll set a second graph on our front panel. We'll click right, we'll choose it, and we'll stretch this a little bit longer because it's going to show all the data that we acquire over time. Now we're ready to go back to the block diagram. You can see our two icons for our waveform graphs right here. We're going to click the right mouse button and we're going to set up our acquisition. We'll go into the DAC Assistant and we'll drop it on the diagram. And this is going to let us set up our data acquisition by answering some menu-driven questions. We'll acquire signals, analog input, voltage, and we'll do it on analog input channel 0. Next, we'll set up some parameters for this acquisition. Our device can go between plus and minus 10 volts, so we'll specify that right here. Next, we want to set the terminal configuration to be referenced single-ended. And then finally, we want to do continuous samples, which simply means there'll be no gaps between our data. So this will now configure our data acquisition function, and it's going to ask us one more question here, and that is, do we want to put this inside a loop? And the answer is yes, because this is a continuous, gap-free acquisition. Next, we're going to wire our waveform graph up to the output of the DAC Assistant so that we can see the data that we're acquiring as it is being acquired. Next, what we would like to do is write this data into a file. So we'll click right, we'll go to File I/O, and we will choose the Write to Measurement File function. So we drop this inside of our loop, and it's going to open up an assistant that allows us to specify some things about how we want to store this data. We'll choose binary TDMS, we will choose one header only, and then we'll have one column per channel, and that will set up how we wish to store the data as we log it into a file. Next, what we have to do is wire the data up to this write function so that we can see it. So we'll move this back over and we'll just go and wire the output of the data acquisition assistant function into the input of the write to measurement file. And now we're ready to go, and that'll store it off into a file. The last thing that we want to do is read that back out. So after everything has been acquired here, we would like to go and see all the data that we acquired for the whole period of time that we acquired it. So we'll go back into our File I/O, and in this time we'll do a read from measurement file. So we'll drop this to the right hand side, and it's going to open up a series of questions that let us specify how we wish to read the data back out. So in this case we'll do it as binary, and that's all we need to specify here. We click OK, and then we need to take the data that we read and send it up to our waveform graph. So we'll wire that up to our secondary larger waveform graph. Now we need to make sure that the read happens after the write is finished, so we'll wire the error lines across here, and that'll make sure that the order of execution is preserved. But at this point we're done with our program, and now we're ready to go and log our data. So we'll start our program up and we'll get it running, and I'm going to reach over and I'm going to turn our potentiometer, and what you'll see is that level is going to change here. So we'll see that it goes up and down, it changes values. If I move it a little faster, it's a bit faster there, but we've acquired our data, and then when we stop the program from running, it will now go and read that data out of the file, and it'll put it in our second waveform graph so that we can see it on the screen. So we've been able to set up our data acquisition, we've been able to set up our user interface with the USB 6009 in LabVIEW, and this is how you perform data logging with the USB 6009.